Hello and welcome to section 1.2a functions, and in this section we're going to talk about whether a function exists or not, whether it's a function or what we call a relation. And a function, basically by definition here, we're testing for functions, is up top up here. A function occurs when an equation is 1-to-1, meaning that for every x there is only one y value. And the way you've dealt with this before was a lot of times you'd graph the equation and you would do a vertical line test, and the vertical line test will show whether or not, because if I have something that I think is a function and it graphs like this, well, anywhere that I draw a vertical line, for these vertical lines are my x values, and you'll notice that there's only one y value for every x. You could also, if I had something that I thought was a function that looked like this, you'll notice that this is not a function, because for every x value where I draw a vertical line, there are two y values, so that's not 1-to-1. So these are the differences between the two, and so we're going to test and see if these two equations could be considered functions or not. So the first thing I'm going to do is I'm going to solve this thing for y. So if I take this equation and say y equals, by subtracting negative x squared across the equal sign, so I'm going to take minus x squared, I get something that looks like this. Now, with that being said, you should be able to notice that that any x value that I plug in here, I will get a different y value. And you could graph this on your calculator and see it, but basically what you're going to get when you graph this thing is it's up +1, and the graph would look like that, more or less. And so you could notice that for every x value, there's only one y value, so that means that this is a function. So this is a function up here, and that's what we were looking for. Well, let's see if this one's a function down here. It looks very similar, but you'll notice that if I add my x across the equal sign, I have y squared equals x plus 1. And now if I take the square root of y on both sides, I end up with plus, since I'm personally solving for y and taking the square root, I end up with something that looks like this, a plus or a minus value. Well, what happens here is that in this function, if I pick an x value, there's a possibility of two y values. So for example, let's just pick x equals 3. If x equaled 3, watch what happens. So in this equation, I would say y equals plus or minus the square root of 3 plus 1. Well, y will equal plus or minus the square root of 4, which means that this equation has two solutions for y when x was 3. So that goes back to this guy up here, the one I did with the red vertical lines, is that this is not a function, because for every x value that I plug in, there's a possibility that there are two different y values, which is what I found down here. So be careful of this. So this is not a function. This is what we call a relation. So then, something that people get confused about is function notation. Well, just remember that in function notation, your x value is your input, your f of x is your output, and then you might have an equation that looks something like this. Now, I did down here the y equals mx plus b versus f of x equals mx plus b. Now, there really is no difference between the two, but what you'll notice is that I'm replacing the y here with the f of x. So that's really all that's happening, is that I'm just replacing one for the other. And the reason that we can do this is that given the x input value, then I can keep track of what x I put into the equation and get a y and find my y value. Where over here, it's very hard for me to keep track. So like, for example, if I said, oh, what if x is -1? Well, if x is -1 in my slope-intercept equation, I get y equals 3 times -1 plus 2, and then y equals -3 plus 2, and in this case y is -1. Well, fine, you get an equation, but you have to look back to see what you plugged in. In function notation, you can keep track of what you plugged in by putting in the -1 in the parentheses. And so by putting the -1 in here, that doesn't say I'm doing anything. It's just telling me that I'm replacing all x's in the equation with -1. So that gives me 3, negative 1 plus 2. And so then f of negative 1 is negative 3 plus 2. And then f of negative 1 equals negative 1. So what this tells me down here is that basically I have an ordered pair of x is negative 1 and y is negative 1 in this equation. And so it's just a matter of the function notation, which people get confused on, is that this looks really confusing and you feel like you got to do something to this side. Well, you're just telling us by using this, by plugging in a value into the x, what value you plugged in, so that at the end you can look at your ordered pair and see everything that you have. And so this concludes our video for section 1.2a, functions, and if you have any questions, please come to class prepared to ask them.